different shortcuts, rules, formulas to find derivatives for various functions. Data set. The next rule for our focus is called the product rule. Product refers to what operation now? Add, subtract, multiply, divide. Product means to multiply. So how do I take the derivative of two functions that are being multiplied together? That's what the product rule is going to help us figure that out. A function, I'll call it h of x. That is the product of two other functions, f of x times g of x. The product rule helps us find the derivative of functions written as the product of one function times another. I'm going to kind of run through the limit definition proof of where this formula comes from so that you can kind of see what thought process is in the background of using this shortcut, using this differentiation. So how do I find the derivative of h prime of x? How do I find the derivative of a function f of x times another function g of x? Well, using the limit definition, the limit as h goes to 0 of f of x plus h times g of x plus h. I'm trying to find the derivative of f of x times g of x using the limit definition. So the first step is to take our function and substitute in x plus h minus f of x times g of x, all divided by h. Little algebra trick that's going to come next here. We're going to basically add a clever form of nothing. I'm going to add a clever form of 0. I'm going to add and subtract the same thing so that I can kind of rewrite my function here, rewrite my limit definition, but I'm not changing anything as well. So I'm going to bring down exactly what I started with. The limit as h goes to 0 of f of x plus h times g of x plus h. Now, I'm going to add on g of x times f of x plus h. Because I added that, I still want to keep it balanced, I need to also subtract the same thing, so that I've essentially added nothing to my limit so far. So I'm going to subtract the exact same thing. So I've written that in blue, so we can see how the previous line changes to what I have down below. I changed one thing here. I put a minus sign and plus sign in the wrong way. Put minus here. It'll fit a little bit better if I write it like that. Or subtract and add the same thing, so I essentially change it. Okay, let's try and factor what I have on top. I've got 4 terms. Let's group them into the first pair and second pair. Looking at what I have to start, these first 2, is there any common factor that I could take out? Is there any common factor between those 2 terms in the numerator?
F of x plus h.
So let's factor that out. I see an f of x plus h in each of the 2 terms here and here. So the limit as h goes to 0 of f of x plus h times g of x plus h minus g of x, all divided by h. I put the f of x plus h as a factor out here, and whatever was left over, g of x plus h minus g of x, all divided by h, I grouped together in this quantity. Let's do the same thing with the next set. This second pair of 2 on top has what common factor?
G of x.
So very similarly, let's factor out g of x. When I take out g of x, I have f of x plus h minus f of x all divided by h. Okay, now let's finish this up. Let's take the limit as h goes to 0. As h becomes 0, f of x plus h is really just f of x plus 0, because h is going to 0. So it's essentially just f of x plus nothing. So this should be f of x. As h goes to 0, f of x plus h, f of x plus 0 is simply just f of x. Does that make sense? As h goes to 0, this is notation for what? G of x plus h minus g of x all divided by h. That's just the notation for the derivative of the second function. This is the derivative of g of x. This is the limit definition derivative for g of x. I'm going to call that g prime of x. This is the limit definition of the derivative of function g of x. Look at what I have next here. As h goes to 0, g of x stays g of x. H has no impact on g of x. What is this notation for? Here at this block, in this quantity. F of x plus h minus f of x all divided by h. That's really just what? Derivative of what function, Michelle? So derivative of f of x, or our notation f prime of x. The derivative of f of x times g of x, the derivative of the product of two functions, is f of x times g prime of x plus g of x times f prime of x. Now, I remember this kind of like a little song I sing to myself. A little kind of chant I run through to myself. F of x, I call this the first function. G of x, I call that the second function in the pair. The first times the second. The derivative of the first times the second is the first times the derivative of the second plus the second times the derivative of the first. The product rule is the first times the derivative of the second plus the second times the derivative of the first. First times the derivative of the second plus the second times the derivative of the first. On your formula sheet, this would be number 3. The derivative of the product of function u times function v is the first function u times the derivative of the second function plus the second function v times the derivative of the first function u. All right. Ran through the proof of the product rule. Now let's apply it to a couple of given functions.
Are you getting it?
Okay. I want to find the derivative of function y equals 3x minus 2x squared times quantity 5 plus 4x. We're talking about the product rule. What does product mean? Product means what mathematical operation? Multiplication. So what two functions are multiplying together? In this function, which two functions, which two things are being multiplied together? I've grouped them how? What's the first thing? 3x minus 2x squared. That's multiplying with what other thing? So I have one function times another function. I can find the derivative of this using the product rule. So I'm going to call this piece the first function. this piece of the second. I kind of say to myself, all right, product rule says that this derivative should be the first times the derivative of the second plus the second times the derivative of the first, using this formula we proved. Right? So dy dx equals the first. So I'm just literally going to bring this down. Rewrite the first function, 3x minus 2x squared. So take the first times the derivative of the second. What I've underlined for the second function, what is its derivative? What's the derivative of 5 plus 4x? Should just be 4. Derivative of 5 is a constant, that's nothing. Derivative of 4x should just be 4. Plus the second, so I'm going to bring down 5 plus 4x. I'm just going to recopy that second function I've underlined. Plus the second times the derivative of the first. What I've underlined in the first pair, what is the derivative of 3x minus 2x squared? 3x has a derivative of 3, 2x squared should be 4x. There is my derivative right now using the product rule. First times the derivative of the second plus the second times the derivative of the first. Pairing each of those products up. Now I'm going to simplify this a little bit just by multiplying and distributing. But all the calculus work is done. The rest is just a little bit of algebra to clean it up. 3x times 4, 12x. 2x squared times 4, 8x squared. See, I've got to multiply 5 times 3 minus 4x, so that should be 15 minus 20x. Take 4x times the same 3x minus 4x, so 12x minus 16. What can I combine? Just all these like terms, all the quadratic terms, linear terms, and constants that I can combine. Let's do so. Negative 8x squared and negative 16x squared is a negative 24 squared. Cool. I've got 12x and 12x to make 24x. When I subtract 20x, now it's just plus 4x. One last one to bring down is the plus 15. Here's your final simplified version of the given derivative. Using product rule, we found the derivative of negative 24x squared plus 4x plus 15. Did I have to use product rule in order to find this derivative? Or could I have done it a different way? Look back at the original equation. How might I have rewritten this a little bit different? Couldn't I just have expanded it all out first? Take 3x times 5 plus 4x, take negative 2x squared times 5 plus 4x, put it back in kind of expanded form, and then take the derivative of whatever that was. Could have done that, would have gotten the same thing, right? Would have gotten the same thing. You're going to have to multiply it anyway after you get the product rule put together. I can use product rule for this right now, the way it's written. Another one. Next up, y equals 3x squared sine x. Y equals 3x squared sine x. Maybe it's not quite as obvious what the first and second functions in that f of x function are. So like I underlined them here in green to start this particular example, let's do the same thing here. What are the first and second functions?
First is 3x squared.
What is that multiplying with for the second function? I have the product of two different things, a 3x squared as one function written first, multiplied with the second function sin x coming after that. So this is the product of two different things, two different functions. And I can use product rule to find its derivative. Take the first times the derivative of the second, then add on the second times the derivative of the first. Unfortunately, unlike number one, I couldn't simplify this any further and get the derivative without the product rule. I have to use the product rule to find this derivative the way it's written right now because it's got a trig function. All right, so let's get f prime of x. Just kind of sing this to myself. Take the first 3x squared times the derivative of the second. What's the derivative of sin x? Cos x. Plus the second sin x times the derivative of the first. What's the derivative of 3x squared? 6x. We're getting good at taking basic derivatives. Excellent. 3x squared should be 6x for its derivative. Using a power rule. So if I just kind of rearrange this here, f prime of x, I like to put sin x first, so just do 6x sin x plus 3x squared of sin x. There's really nothing to do to clean up other than just write them out like that. Nothing to do algebraically to clean that up other than just writing it out. The derivative of 3x squared sin x is 6x sin x plus 3x squared cosine x. People always get product rule confused because they just want to take the derivative of the first times the derivative of the second. But there's more work to it than that, as we've kind of seen with product rules so far. Questions, guys? Okay. Let me give you one to try. Do this derivative, please. What is the derivative of 2x sin x minus 7 cosine x? Take it term by term. Let me get you started. Take it term by term. The first term is 2x sin x. Like I need product rule because what two functions are being multiplied together in 2x times sin x? 7. What's the first function? 2x. Underline that and say that's the first. What's the second function? What's multiplying with 2x?
Sin x.
Use the product rule to differentiate. And find the derivative of the next term, term by term by term. Yes, this is the constant multiple rule. That's the sum and difference rule. Yeah. Because the derivative of, for example, the derivative of 3x squared is 3 times the derivative of x squared. So it's 3 times 2x or 6x. That's an example of the CF constant. Yep, we had like a bunch of basic ones to start, now we're kind of adding them on one at a time. We've got product rule here, number 3 today, we'll do portion later this week. We have a lot of log functions and restrict functions to work on. We're gonna do the top 2, first one. We don't do hyperbolic functions.
Is there a reason you write sign?
It's personal habit.
I don't know if that was supposed to heard it now.
I think that's just kind of a common convention, but addition works the same forwards and backwards, so does it matter the order you put it in? If you had 2x cosine x plus 9 sine x, it's the exact same.
Because you dropped off no ring. Isn't it
So, doing the process of
Now, do you really need product rule for 7 cosine x? I mean, you can. What's the derivative of 7 cosine x? Wouldn't it just be 7 times the derivative of cosine x? Because it's a constant times a function, not a function times a function. Derivative of the second half would be plus 7 cosine, plus 7 sine x, pardon. Because negative 7 times the derivative of cosine would be negative 7 times negative sine x, or positive 7 sine x. This one, you have to use product rule, because it's a function times a function. This one, you could use product rule, it would be fine, but it's probably not the quickest way to do it.
So then it'd be the first half plus isn't that? So
It'd be the first half times the derivative of the second.
yeah. After that.
Yeah. Looking at this rule here, the derivative of a constant times some given function is that constant times the derivative of the given function.
Yeah.
Product rule necessary, product rule optional, but probably not the most efficient. Does that make sense? All right, let's see what we got here. Doing product rule for 2x sine x.
Oh.
I know that derivative of y with respect to x equals the first times the derivative of the second plus the second times the derivative of the first. What I've written out right now is simply the derivative of the first term. Does that make sense?
Yes.
Derivative of 7 cosine x. That would be 7 times the derivative of cosine. I don't need the product rule here. You could, but you don't have to. I think there's a quicker way to do it. What's the derivative of cosine x?
Negative sign.
So this would be negative 7 times negative sine x, or positive 7 sine x. If you wanted to call this the first and this the second, and then do product rule, you could. It would just be more work than absolutely necessary. This is a function times a function. This is a constant. 7's a constant times another function. So I don't have to use product rule unless I really, really want to. So derivative is 7 sine x plus 2 sine x makes 9 sine x plus another 2x cosine x. Lots there, guys. Problems, questions, product rule, differentiation. Okay, we got about 9-10 minutes left, so I will leave the remaining time we have together left to do some practice problems on Schoology. If you want to grab your laptops and find some good practice on that.
Why did I take my AirPods?